Are the triangles below acute, obtuse, or right? So for angle A, all of the angles are acute, so it is an acute triangle. All angles are acute, so it is going to be an acute triangle. So acute angles are less than 90 degrees. Less than 90 degrees. So all of these angles are less than 90, so it's an acute triangle. For the next one, triangle B, it has one obtuse angle. One obtuse angle. So therefore, it is an obtuse triangle. And all you need is one obtuse angle for it to be an obtuse triangle. Notice that the other two angles are actually acute, but if it has one obtuse angle, then it is obtuse. And obtuse angles are more than 90 degrees. So 120 is greater than 90, so that is obtuse. Okay, and then triangle C has this little square here, so it has one right angle equal to 90 degrees, so therefore it's a right triangle. And then same with this one, right angle, so therefore it's a right triangle. If it has one right angle, it's a right triangle. Okay, then number 2, it says what is the value of x? The interior angles of a triangle add to 180, so interior angles of a triangle add to 180, thank you Erica, degrees. So therefore, these three angles add to 180 degrees, so we can do 180 minus 51 minus 35, and whatever's left over is this angle here. So if you were to plug this in a calculator, it comes out to 94, and that is your answer. This is 94 degrees. Okay, and then the next one, for this one, it asks for the value of x. This is an exterior angle. If you add the remote interior angles together, then it'll equal this exterior angle. So you can add 60 plus 81, comes out to 141 degrees, and that is your angle here. And that's how you get that. Some of the questions when you get on ALEKs, it'll have like x right here that you're solving for. To find like this angle, you would just take this number, subtract this, and you'd find this number. Okay, and then over here it says that line L and M are parallel, find the measure of x. So when you have parallel lines, the transversals make all sorts of equal angles. So this transversal, the alternate interior angles are equal. So if this is 29 degrees, this is 29 degrees, and we can kind of solve it this way. There's multiple ways to solve this, but this would be one. Alternate interior angles are equal, so if this is 29, this is 29. Then you could find this angle right here, so you can do 180, because these three angles add to 180. 180 minus 101 minus 29 equals 50 degrees. So 50 degrees goes right here. And then from here, these two are supplementary because they form a linear pair. So we can do 180 minus 50 equals 130 degrees. Like that. So it's kind of like a puzzle. You fill in what you know until you can get to the x. Are you thinking of another way to do it? Correct. So he's saying if you use this as a transversal, and you know that alternate interior angles are equal, then 101 plus 29 would equal this angle here. So yes, if you see it that way, you could do that as well. Okay, the next one, it shows a triangle. It asks you to find the measure of each angle, but instead of numbers, it gives you like expressions. So we're trying to find the measure of angle J, the measure of angle I, and the measure of angle K. So right off the bat, like I see a little square right here, that means J is 90 degrees, and I can fill that in and make sure I get that right, because on ALEKs, it'll give you partial credit when you get like part of it right, which is cool. So I'm definitely going to get at least a third of the points there. Then from here, I'm going to need to solve for x. these three angles add to 180, so I'm going to set up an expression. So 90 degrees plus this expression, 3x plus 16, plus this angle, 5x minus 38, equals 180 degrees, and I can use this to solve for x. Then once I have x, I can plug it in to find these angles. So to solve this, I'm going to combine like terms, so I get 8x. Then I'm going to add the constant, so 90 plus 16 minus 38 comes out to 68. I didn't do that in my head, I just did it with a calculator last class. Equals 180. And then continue solving, subtract 68 from both sides. 8x equals 112. Divide by 8. X equals 14. So we got what x equals, and now I can solve for I and k. So measure of angle I is 3x plus 16, and I can plug in the x. So 3 times 14 plus 16. So 3 times 14 is 42 plus 16. Measure of angle I is 58. Yeah, good job. So this here, 58 degrees, 58 degrees. To find the third angle, you could do 180 minus these two numbers to get the third angle. You could also just plug in 14 into this expression. So measure of angle K, 5 times 14 minus 38. Measure of angle K is 32. Like that. And you could even check it by doing 180 minus 90 minus 58. And does that equal 32? And it will. Okay, and then number 6 over here, it says you have two congruent triangles. It asks you to identify corresponding parts, so it wants matching parts. So we're going to find matching angles. Remember, you're looking for the same amount of arcs. So angle A is congruent to angle what in this picture? It has two arcs here, so we're looking for the two arcs here would be y. Then angle B with three arcs would be equal to x. And then C with one arc would be equal to Z with one arc over here. So again, you're just matching parts. Then you're going to match segments. So AB, segment AB has one little mark here. So I'm looking for the one with one little mark. XY has one little mark. AC has three tallies. So ZY has three tallies over here. And then BC has two tallies. So over here, XZ. By the way, the reason why I put a line through the Z is so it doesn't look like a 2. In math, that's really helpful if it doesn't look like a 2.
Same thing, switch.
Yes, it is the same thing. Yeah, if you switch the order of the letters in this problem, that's okay. Yeah, that would be fine. But with the triangle congruence, it's not like it has to be in a specific order. So ACB, I'm looking at that order. ACB, it's like 3 tallies, then 2. And I need to make sure the same order for this. So I need to go 3 tallies, then 2. So I'm going to go this way, then this way when I name the coordinates. Y, Z, wait. Yeah, Y, Z, X. Yeah, we're good. Y, Z, X. And you can also match the angle. So A should match angle Y, and it does. C should match angle Z, and it does. So we're good. Okay, and then the bottom here, it wants to know whether these are congruent or whether we can prove they're congruent. And what congruent statement could we use? Let's see. So here I see a side, and then the shared side would be equal to itself. So I can prove they are congruent by side. And then for the congruent statement, I need to make sure that it's in the right order. So UVW is like one tally, then 3. So XWV would be equal to that. XWV. And then for B, I have angle, and then angle, side. Both of those are congruent statements, but in order to use one of them, they both have to have the same like matching parts, and angle, side, angle. It would need to be angle, side, angle over here too. So this one's not necessarily congruent. They might be congruent, but we can't prove it. And then when you put not necessarily congruent, you don't have to fill in any of this. And then for C, we have angle, side, angle, and then matching angle, side, angle. So therefore, we can prove they're congruent. Notice how it's flipped, like the one tally is on this side and one is on here. But even when you reflect the shape, it's still congruent as long as it has the matching angle, side, angle. And then we'd put angle, side, angle here. And then for the triangle congruence, A, B, C is 2 tallies, then 1. So I need to do 2 tallies and 1, so F, D, E. And then when you're done with that, we'll flip the page. You can switch colors too to switch it up. Okay, now we're going to look at some proofs. The same situations happen over and over with the proofs, so once you do a couple, it'll get a lot easier. So don't shy away from them or don't feel like they're impossible, because the same situations come up over and over again. So in this, we're always going to start with the given, and they filled in some of the blanks for us. So the given, EF is congruent to HF. We need to just copy this here. So HF is what you type in here. As I look at the given, I'm also going to mark up the picture so that way I can see visually what's going on. EF is equal to HF. Those are congruent. And then the second given is DF is congruent to GF. DF is congruent to GF. And the reason here, given. Okay, and then the third part, it says vertical angles property, and it has like a blanket wants you to fill in here. So I'm going to look at DFE, like connect the dots. DFE is this angle, and then vertical angle property would mean that this angle is the same as that, and I just need to name that angle, HFG. You could also name it GFH, but the vertex of that angle has to be the middle letter. So those are congruent because of vertical angle property. And then to prove these triangles congruent, we have side angle, side angle, side. So that's what you would choose here. And there's a drop down here, like with a bunch of choices. So you just choose the choice. And also on the computer, you can't really like tally on the computer very well. You could sketch this out on a piece of paper and write on it, which would be helpful. You could also kind of visually remember where parts are, but yeah. And then over here, we're going to do another proof. It says use the given information to prove that these two triangles are congruent. Starting with the given, it says PRQ is a right angle. And again, just making a mark on here so I can see it visually, it will really help. It says PRS is a right angle. PRS, right angle. And it says that QPR and SPR are congruent. So QPR right here and SPR are congruent. So these two angles are congruent. Okay, so now I'm going to look at the proof. Let's see. PRQ is a right angle given. This is a right angle given. We drew it on there. And now it's saying that PRQ and PRS are equal. That is because all right angles are congruent. And that's an actual reason in the drop down. So all right angles are congruent, so therefore they equal each other. Then it says given again. It's talking about this third given statement. QPR is congruent to SPR. We already marked it on there. Then the next says reflexive property. It's just wanting you to say that PR is equal to itself since it's a shared side. So we'd write PR right here. And then we can prove that these triangles are congruent because we have angle, side, angle, angle, side, angle. Okay, next for this one, this is one of the newer question types this week. For each pair of triangles, determine whether the hypotenuse-leg congruence property can be used to prove that these triangles are congruent. So hypotenuse-leg can only be used for right triangles, and it means that you have, of course, a right triangle, and you have a hypotenuse in common, and you have a leg in common, like this. It's actually angle side side, but we don't call it ASS theorem, we call it hypotenuse leg. A hypotenuse in common and a leg in common. So that's what we're looking for with these. So can the HL congruence property be used? Let's see. So we have right angles, we have right triangles, we have a leg in common, and then the shared side would be in common. So we do have a hypotenuse in common and a leg in common, so it'd be yes. Or B, we have right angle, which is good, but it doesn't say that the hypotenuse is the same length, so we don't have enough info. Not enough info. So this would be no. They might be congruent, but we can't prove it. Then for this one, can hypotenuse leg congruence be used? We don't have right triangles. Not right triangles. So therefore, no, because hypotenuse leg can only be used with right triangles. And then for D, we have the right triangle, good. We have a hypotenuse in common, they're both the same length, and a leg that's the same length, so therefore, yes. Okay, and then number 11, for each triangle, check all that apply. So it's talking about either isosceles, equilateral, or scalene. All three sides are the same length, so be equilateral. All sides equal. So that would mean equilateral. It is also isosceles because isosceles is two sides equal. Two sides equal. And it does have two sides equal. And then equilateral is all sides equal. So it's actually both for that one. And then for triangle B, we have two sides in common. That is isosceles, two sides equal. For C, two sides equal, isosceles again. And then scalene, I know it's not in the example, but I want to go over it in case you get it on the test. So for scalene, scalene is all different side lengths. So like scalene would be like maybe something like this, like 4, 6, and 7, like all different side lengths would be scalene. And then the last problem, we're going to go up here, question 12. It says, for each part below, use a figure to fill in the blank. If necessary, you may learn what the markings in the figure indicate. Okay, so this is what we did yesterday. It says find the measure of angle K. So this is what we're solving for right here. It shows that these two sides are the same length. So therefore, the base angles are going to be the same measure. So if this is 40 degrees, this is 40 degrees. But we're solving for K. So to find this last angle, we're just going to do 180 minus 40 minus 40, and whatever's left over is K. So that would be 100 degrees. So this would be 100 degrees. Okay, and then for HI, so it's talking about this segment here, it shows that all the angles are the same length, so therefore all the side lengths are going to be the same. If this is 7, this is 7, and this is 7. So the length of HI would just be 7. Okay, so now what you're going to do, leave this out so I can give you credit for it. You're going to do chapter 5 practice test on ALEKs. So grab a computer and work on that practice test. And if you have questions, please ask so I can help you. Yes, you may. Just sign out, please. And don't take forever. Because other people have to pee too. What? After Gabriel gets back. He's leaving.